Hello, in this video I'm going to go through some more protocols. Now in the last video I went through TCP, UDP and IP. Those three are really the big hitters of protocols, but here are some more. Some you'll recognise of course, but a lot more acronyms, a lot more terms to know, unfortunately. So the first one you would have heard of for sure is HTTP. It stands for Hypertext Transfer Protocol and it works at the application layer. So really what that means is it's the final stage when you are transferring data. So either it starts a process or it ends a process because it's right at the top layer. Now, what hypertext is just some text on a website with some link to other hypertext. So you've heard of hyperlinks, the links you click on, those are what are in hypertext. So really we're writing websites in a language called HTML that causes the hypertext to get made, and so HTTP is used with it. So really this protocol is used for accessing a web page written in HTML made up of hypertext from a server, and in particular a web server. So the idea is you'll have a client. The client will be what is requesting a website, and there'll be a web server that is what is providing the website written in HTML code plus other code usually. And the idea is via HTTP, the client will request the web page or send a message requesting it, and hopefully the web server will respond and reply with the web page. So that's how it works when you access websites. Your browser will use HTTP to ask for and hopefully receive a web page. And as hopefully YouTube is using right now, you'll actually be using HTTPS. Now HTTPS is the secure version. It uses encryption to make sure that message is kept private from anybody else. Another protocol which does what it says on the tin is FTP, which stands for File Transfer Protocol. And these acronyms you should be learning really. Also you should be learning at what layer they work at, and FTP also works at the application layer. So FTP, as the name suggests, moves files around. You upload and download files using FTP. Now, a slightly important distinction is usually FTP is transferring data and programs, not your typical viewable content. So right now, this video you're watching, any downloads, any web pages are not transferred by FTP. FTP is usually for bigger chunks of data, including whole websites. So you may not have used FTP, but it is used in networks quite a lot. And just another detail potentially might be useful. FTP often needs a login to use. So to stop somebody just accessing a really important program on a server, you might have a login just to prevent anyone random using FTP to access sensitive information. Another protocol to cover is SNMP, which stands for Simple Network Management Protocol. I think this is very cruel to have because it sounds so similar to another protocol we're going to have later, which is SNTP. This is SNMP. And what SNMP does is collect information from devices connected to the network. So really, its job is to suck up lots of hopefully valuable information about how the network is working. That's why the M is for management. It's managing key information in the network. And often it's managed from a device like a router. So the software running in the router, the protocol running in the router, will ask for information from the devices connected to it and receive it. Usually this information will be things like statistics on information such as the traffic, so how much is going on, how many messages are getting sent, but also errors. So are there issues in the network? Is one device constantly causing issues or receiving issues? This protocol will help the manager of the network, the human, understand what's going on to try and fix issues. Another protocol, I think our fourth, I'm losing track a little bit, is POP. Now that's a stupid sounding name. What POP stands for is Post Office Protocol, which also sounds a little bit odd. This, like the others, works at the application layer too. Now the name makes more sense when you realise that POP is used to download emails. So in the same way that a real post office deals with letters and parcels, POP in IT is about emails. So specifically connecting to email servers as opposed to standard web servers or print servers or things like this. And that downloading is important. So the job of POP is to download stuff, which again, if you're thinking of a real post office as an analogy, you might have a parcel and it might get left at the post office. You might have to go and collect it to bring it back to you. I guess that's kind of what POP does, right? You have your laptop, you have your computer, and you'll go via the internet to connect to a mail server. So when you get an email, the email will be stored on a mail server and you can only access it via a protocol like POP. So when you are checking your emails on your phone, on your computer, the actual checking process involves using a protocol like POP to download it from the mail server. The mail server will be owned by a company like Google for Gmail or Hotmail or whatever, and it will hold lots of emails. You've got to download them to view them. Now that is for inbound email you are downloading. In terms of uploading email, that will be done using a protocol like SMTP. SMTP is a very unhelpful acronym because it stands for Simple Mail Transfer Protocol. And that transfer doesn't tell you what direction, but SMTP is used for sending emails. So you send emails to email servers, but also actually, I guess the transfer comes into the fact that SMTP is also used to transfer emails between servers. So for example, if we now have a few more mail servers in the mix, if you are sending an email, you'll use something like SMTP to send it to your mail server. And that might have to send it to another mail server if you are, say, emailing somebody using a different domain. So if, for example, you're emailing somebody who's got a office.com address and you're emailing from a Gmail address, you'll have to pass through 2 at least mail servers. And SMTP is used for connections between mail servers as well. But ultimately, if you're sending email, you'll use a protocol like SMTP. If you are downloading email and receiving email, it will use a protocol like POP. Now, the last protocol to mention is a bit of an outlier in this video because ICMP does not work at the application layer. All of the other protocols work at the very top layer, which is when stuff is initiated from and stuff ends. But ICMP, which stands for Internet Control Message Protocol, works at the network layer. Now, the network layer is either the second or third layer, depending on if you're looking from the bottom or top, but it sits just above things like Ethernet and Wi-Fi in the link layer. And at the network layer, you've also got IP. So the Internet Protocol, IP, works at the same layer as ICMP. And that's important because they work together. Now, what this protocol does, not that you'd know from its name, the name is quite vague, but what ICMP does is troubleshoot issues on networks. Now, troubleshooting is finding out what the problems are. That is what ICMP is used for. And I said it works with IP. Specifically, it will send messages back and forth when there are issues with the Internet Protocol. So for example, if it can't find a device because of its IP address, if it has an issue routing it in a network, ICMP will kick in and send error messages. Another common example which you might have heard before is ping. So the ping test uses ICMP. So when you ping an IP address, when you ping a device, that will use ICMP. Now, pinging is where you send a message to a device and count how long it takes for you to get a reply. The idea being that you can see how slow it is. First of all, it might take a long time. That might indicate some error. But equally, you might never get a reply. If you try and communicate with a device and never get a reply, that suggests there is quite a bad issue somewhere in the network. So here, for example, and you can try this on your own computer, is if you ping, say, google.com, what this will do is send a few packets to that IP address. You can see it's converted google.com to the IP address, and it times how long it takes and gives you the average and gives you how many packets were lost. In this case, it took on average 17 milliseconds and no packets were lost. If there was an error, it would either take much longer or you'd have some packets being lost. And so you could tell and try and investigate the issue. So ICMP is used to find issues on networks. It works closely with IP, which is why it works on the network layer.